All right, guys, welcome. We are going to go through and talk about the. Uh, we're going to go in and talk about the third law today, and we're also going to be able to go through and look at the um, setup for the most part with the review and things like that we're going to have um, up until our quiz that we're getting ready to have. So. A couple of reminders. First off, the quiz is going to be on Thursday. Okay, so um, the important thing is going to be to make sure that we understand what it is that we got going on and what we have coming up. Um, and uh, the goal for us is to be able to be as successful on our quiz as possible. Okay. The just as a reminder, we've already talked about this over and over, but the YouTube videos and that sort of thing are on your homepage. Okay, so if you go um, to the page for this particular class, you'll actually be able to see um, basically all of the um, YouTube videos and things like that, where we go through the notes as well as directions for things or stuff like that. Um, the other thing that I forgot about to talk to and remind second period about is um, tutoring. Okay, they have made tutoring or an opportunity for tutoring in the mornings. Okay, at 9:15, from 9:15 until I guess 10. I'm not really sure how long. I had a few questions that I answered this morning and things like that. So what'll happen is when you come into tutoring, it will send me an email. And it'll say, hey, and I have my computer up anyway. It'll say such and such has joined your meeting. Okay, and I will come in and a few seconds after that. I don't have it just up, okay, because it drains battery power and a number of other things. But that's kind of what it's going to give you a really good opportunity when you're already supposed to be in school. So there's really not a whole lot of excuse or anything like that for um, if you need assistance going to a tutoring, not necessarily my tutoring. Okay, if you have an A in here or a B in here, or you're satisfied with whatever grade you have, obviously you would need to worry about another class and vice versa. But that's going to be the main thing. The other thing is, remember, for those of you who want to be remote learning or want to be in-person instruction and you're not, okay, you can contact your counselors, and your counselors will be able to set you up with switching you from one or the other. If you are happy with where you are, if you're remote and you want to stay remote and things like that, you don't have to do anything. But just know the deadline for that for that is December 4th. Okay, and that's going to be stuff that you have. So, quiz on Thursday. We're going to review and go through some things, um, and talk about what we're going to do today as well. So, the first thing is today we are going to talk about Newton's third law. Okay, and I told you I'm a nerd, so I'm a part of all these different um, sites or these different things for teaching science, right? And so one of the things that I saw the other day was this, and it's about Newton's third law. Okay, we're going to talk about it today, but yeah, I think it's going to be interesting to see that there's a few idiots that are doing things that they don't understand Newton's third law. Okay, and there's always an application for these laws in your life. Always. So let's check this video out real quick and then we'll talk about some more stuff. Listen to the music. He got hit right in the face. Right in the face. He doesn't understand Newton. Oh, she doesn't understand Newton. I hit her right in the face. Watch this one. Yeah, that's really, really, really dangerous. Whoops, sorry. And shot, hit himself. You could see it went right, smacked him right in the face. Okay, so the goal for us is to understand that when something happens in one end of a rifle or one end of a substance or one end of a planet or one end of whatever, the equal opportunity or the equal force is going to be pushed on the other side. Okay, so we're going to go through and look at it and talk about it today. Okay, you have a word problem creation. Okay, some of you guys have habitually not followed directions this quarter. Okay, so some of y'all are losing a lot of points on every assignment because, let's say, I just graded some discussions this morning. Okay, and you answered the question very well, but then you didn't respond to another person. Well, you lost points. Okay, in this case, you have an opportunity to do something well, but you also have the potential to lose some points, right? So it says using the acceleration, okay, and we've talked about that acceleration equals the change in velocity over the change in time. Okay, you are going to make up your own word problem. Okay, now just like I told you for your warm up, if you Google something and it has something in it, I know how y'all write. I know how y'all talk. Okay, it is very obvious when you put something in there that you have never seen before. So it's something very easy. Okay, you can even go back and look at the notes. Okay, and I'll put the notes in the chat. Okay, but you can even go back and look at the notes and basically tell me, hey, this is very similar to blah blah blah. This is very similar to blah blah blah. Okay, and you can go in and put basically a very similar question. Don't just copy one of those questions down, but you can put one of those questions in there, and it will allow you to do that. Now, the second part of this, and I'm putting the notes in the chat right now, so it should come through in a second if you need to pull them up because I didn't have the link for today. Okay, we've been using the same notes. But the second part of this is you will notice it says you need to solve at least one other classmate's word problems. So if you do the world's best word problem for this, okay, and you don't solve anybody else's, you lose points. Okay, so make sure that you're putting forth the effort. Don't just check boxes. Hey, I did this. Hey, I did this. Hey, I did this. Because your grade is going to reflect that. Okay. The other thing is a lot of the stuff that I graded, I have put comments on. Take time to go back and look at it. Okay. A lot of them say, hey, you can resubmit it. So if you go in there and do it right, or you go in there and finish the last little direction that I gave you or whatever, I'm going to change your grade. Okay. So you got to make sure that you go in and do that. It's just a battle of making sure you get all your stuff right. Okay. I wanted to spare you all that. So I knew it was coming. So the goal for us today, that's one of the things. And if you look in your chat, the PowerPoint from today is up. Okay. But it's the same PowerPoint we've been using. That's why I didn't really go and put it in a new link. We got enough links up for today. That's the first thing. Okay. The next thing you're going to do, and we're going to go over the notes very briefly. The notes are very simple. We actually probably have more time for videos than we do for notes today. Okay. The next thing is some questions. All right. And this animation is just about Newton's third law. Okay. But the questions are based on an article. Okay. And so if you click on this, if you can't access the form directly, you can click on the link, just like we've been talking about. Okay. And you are going to basically answer these three questions. Okay. The link to the article is right here. Look at it. Okay. And use the article to answer the questions. You will learn it much better. I promise. Okay. So you're going to have plenty of time today to do that. All right. After we do our independent stuff. All right. Originally what I had, if you'll notice, originally what I had is there's a Kahoot in here, okay? What we're going to do is we will do that tomorrow, okay? I didn't do it with second period, mostly because I messed up and didn't have something published. But that way, if you were behind, you have a chance to catch up today. And if you or y'all are behind, most of y'all are actually pretty much caught up. So you'll also have some time today if you've done all your work for my class to work on something else. But you got to make sure that you prioritize that. You'll notice this says this is your grade for the day. Okay, I'm going to go back through and look at these, as well as you may have noticed if you check your PowerSchool, there's a warm-up grade that popped up that I put in second period that you guys are getting as well. So if you did your warm-up, you didn't just Google it, stuff like that, I am putting in a tiny, tiny, tiny little informal grade for that. Okay, so that's basically what we got. Okay, now those are our videos for today. That guy looks a little weird in that one video. Okay, but let's talk a little bit about Newton's laws. Okay, so when we talk about Newton's law, first of all, they summarized it very, very well, and a few of you guys summarized it pretty similarly. Okay, and basically what it is if you are staying still, if you're at rest, something's going to have to bother you before you basically move. And the same thing's happening if you're moving. If you're moving, you're going to keep moving until something stops you or until something makes you basically quit moving. Okay, so what we're going to be able to do is apply these things. In the next few units, we're going to be doing that. Okay, we talked about friction, we talked about inertia. Okay, then the next time we talked about FUMA, or F equals ma. All right, and so what you'll see is the acceleration and the force are proportional, meaning when you push something real hard, it's going to accelerate faster. All right, and that's why I put your meme of the day as this thing here, where the guy stopped the truck and the rock that was in the back of the truck kept going. Okay, that's inertia. That rock was not being stopped by that little aluminum truck. Okay, so I would hate to be this guy in this cab, because you're going, bam, you get hit by a giant rock, basically. But this is what we've been talking about. Okay, sometimes you have more force than can be handled, and that's why you have stuff that breaks and bends and that kind of stuff. So we are going to talk about Newton's third law. Okay, there's a grand total of one slide on this. I'm going to draw a few things. We're going to watch a few videos, and then we're done with it. Okay, so again, we talked about the fact that you want to be able to apply each one of these laws. I'm not going to say, hey, define Newton's third law for me, or which one of these says, or which one of Newton's three laws says for every action there's an equal and opposite reaction. No, but what I want you to understand is the concepts. All right, so when we look at this, one of the things that you're going to see, for every action, there's an equal and opposite reaction. So what that means is anything that's going to make a force go this way is going to be met with an equal force. Okay, and so we're going to go through a couple of examples, but basically something is going to cause a proportional response, a response to happen that is basically the same as what it started with. Okay, so the example that I used last period was, if you're going to throw a ball against the wall, okay, if you're going to throw a ball against the wall, what's going to end up happening is the ball is most likely going to bounce, right? And the ball is most likely going to bounce. So what happens is, you would think the wall is just sitting there and it's the one that does the abusing. It's the one that hits the ball. However, what's really happening, according to Newton, is when this ball hits this wall, is causing force to go into the wall, and the wall is exacting force on the ball. That's why, because the ball is like this, okay, you are basically going through and looking at the idea of the wall is sitting still and then the ball flies off. Okay, they meet with equal force. The difference is, though, one goes away because it's smaller. Okay, so when we look at this, one of the examples, one of the videos that we'll look at is between a big ball and a little ball. Okay, and if you have a big ball, okay, and you have a little ball, and you drop them both, what happens is when they impact each other, okay, you have, let me go back here. When they impact each other, this ball is putting force on this one, and this ball is putting force on this one. Now, what happens, though, is because this ball is smaller, it shoots off. Okay, so if we look at it, I'm going to show you an example of it, okay, but it's kind of cool to see that everything has an equal amount of force on it. Whoops. I can't type apparently. So watch. So when we talk about momentum, one of the things that we're going to have to deal with, hold on, there's a darn commercial. Get out of here. All right, so the homemade science, watch this. Okay, so this would be me in the classroom, basically. Okay, so this guy has a basketball and a tennis ball. They're on top of each other. Okay, so what happens is when they hit, the tennis ball pushes all of its might, all of its force into the basketball. The basketball goes, right. Pushes back with equal force. Well, the difference is, check it out. Look what happened. Okay, so the basketball dropped. Okay, and with more force, let's go here. When you do it the other way, it still does it, but it's not quite the same. Okay, but when you go from a, not that one. Here we go, watch it. Watch the tennis ball fly off. And that's because of the fact that you're going to have equal force on both of these things. Okay, so what you see is because they have equal force, all this is basically doing is a lot of the mass from when it hit the ground, or excuse me, a lot of the force when it hit the ground causes it basically to bounce higher. Okay, and this is something that is pretty common sense if you know about physics, but it's something that really and seriously goes through a lot of the things that we have set up for the most part with regards to all the stuff that we've learned. Okay, now the other thing, check out what happens to this tennis ball when you hit it. Hold on, let me see if there's a better video. I didn't like this video. Not tennis ball, this is a golf ball. Nope, not that one. Oh, that's the one I want. So look, another commercial. Buy a vacuum. All right, so these guys have an air, one of the compressed air things. It's basically like an airbag. Now, watch what happens when they shoot this golf ball really fast at this wall. Okay, now what's happening is that basically, what's happening basically is that you have equal force on both, which is allowing them for the most part to go through and see what happens when you have the force difference. Okay, so apparently they're doing a rocket club. That's not what we want. Okay, here we go. Here we go. Here we go. Well, maybe. Not the one. All right, so here's another one that they do, okay, where it's two pieces of smoke, basically, and they blow them towards each other. All right, and what happens is they go poop and they puff. Okay, so there's a number of explanations and there's a number of things. I'm trying to get to where it is supposed to be. Oh, this is the there we go. All right, so watch this. Oh, I'm trying to get to the right point. All right, they got a lot of air pressure. Don't do this at home. It's going to be a really bad idea. Notice they're wearing the masks and all kinds of stuff. Oh my God, that thing went flying. Did you see it go flying? Holy crap. Anyway, what we're going to do, or what we'll see, there goes the golf ball. Watch it hit. Now, you can see all the force go into the wall and come back. Okay, it's pretty unbelievable. All right, and so watch. Bam! And then it comes back. You didn't know a golf ball could do that. Okay, now granted, they threw it, they shot it at really, 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 really fast speeds. Okay, but the point of it is that you have an equal reaction to each thing. Okay, that's why it went flying off. I don't know that I would necessarily have it shooting around my shop, but that's something that is an explanation for that. Okay, so Newton's third law is for every action, there's an equal and opposite reaction. So let's bring it back to what we were talking about on day one. What we were talking about on day one is the fact that there's a book sitting here. Okay, if that book is pushing down using the force of gravity, okay, there is also a force pushing up, which we talked about is called normal force. Okay, and they have to be equal or crazy things happen. We talked about the fact that your body can explode because you have pressure inside your body. If you were to go into a vacuum like space, poof. Okay, so it's pretty interesting to see that, and it's pretty interesting to understand it, but that's Newton's third law. All right, now, pretty simple. First, second, and third. Okay, very basic. However, they explain just about everything that happens around us. Okay, so what you guys are going to do, again, we're not going to do the Kahoot right now. All right, and I'll show you how to get to that tomorrow, and we'll go in and do it. However, you have the questions, okay, and there's 3 questions based on that article, so you have to go in and do that, and you have to do the word creation, okay? Very, very, very important to do both, okay, for a review for your quiz as well as an application for the stuff that we've been doing, okay? Tomorrow when we come in, we're going to go through the Kahoot, and we're going to have a study guide that we're going to look at. All right, and Thursday, we have a quiz and then some after quiz activities and stuff like that, like we normally do. Okay, so y'all are going to go ahead and get started on that. We are actually going to get back together at about 1:10. So you have about 30 minutes to go through and do that stuff. All right, and then we're going to talk about a couple of different things. I'm going to have some more demonstrations and things with Newton's different laws, and then we'll be done for the day. Okay, so go ahead, get started on that stuff. I'm going to double check and make sure that attendance is accurate and all of that, and we will reconvene, come back together at about 1:10. All right, let me know if you have any questions. All right, make sure that you're asking questions if you have.